12th class, 3rd chapter, current electricity. 15, 16, 17, 18. Session 18. And it's about Wheatstone's bridge. Wheatstone's bridge. It's about Wheatstone's bridge. Let's see. This is a possible question in a board examination for long mark type questions to derive, define and all. It's a set of some resistors. There are so many applications of it also. See, such combination of resistors connected to cell and a galvanometer. See, this is a galvanometer and there are certain cell resistors P, Q, R and S with a cell. Now I can call this as A, B, C, D. Such a combination of resistor and cell and galvanometer we call it as a Wheatstone's bridge. It is not must that the connection here is always galvanometer. There can be any connection. There can be any connection, but if it is a galvanometer, it's okay that we can measure the current also. This is what a Wheatstone's bridge is. Now, what happens? What happens? Current will start to flow from the battery. The main current I, you got it right? It will reach here and it will be splitted as IP, you can say IP, IR and this will reach here, the junction, and let G be the resistance of the galvanometer, IG, the resistance through the galvanometer, and the remaining will flow through this Q and it is IQ, whatever it be. I'm just giving a name, that's all. IQ, if I say IQ. Now this IG will come here, this IR will come here, and at this junction they will unite and that will flow as IS. And this IS and IQ will come at this junction, they will unite and again it become I. This is what the combination says. Okay, that's all. I'm just taking an experiment to put it like IP, IQ, IR and IS. Usually book name the value like I1, I2, I3 and I4. But I'm taking a change just as an experiment so that it will be easy to understand. Now, we say the galvanometer, sorry, this particular setup is known as a Wheatstone's bridge. And the Wheatstone's bridge will be said to be balanced. The Wheatstone's bridge is said to be balanced if there is no current flowing through galvanometer. Means Ig is equal to 0. Isn't it? Such a kind of connection is known as a Wheatstone's bridge. And the Wheatstone's bridge is said to be balanced if the current through the galvanometer is 0 or Ig is equal to 0. Now you may be asking how is it possible and when it will be happening. The condition for the Wheatstone's bridge to be balanced is this Ig will be equal to 0 if the ratio of the resistors are given like P by Q equal to R by S. I will explain once more. This kind of connection is known as a Wheatstone's bridge, and this Wheatstone's bridge is said to be balanced if there is no current flowing through the galvanometer or Ig is equal to 0. And for the Ig to be 0, we need a requirement that P by Q equal to R by S. This is what actually the condition for balancing. Now, this is a plain statement I gave to you, and being a teacher, it's my responsibility to prove it. And I'm going to prove it. I'm going to prove it. And I'm taking the ulta, I'm taking the reverse. Like, if Ig is equal to 0, I will show P by Q equal to what? R by S. If P by Q equal to R by S, Ig will be equal to 0. This is what Wheatstone's bridge balance condition is. If the ratio of the arm resistance is such that P by Q equal to R by S, Ig is equal to 0. This is balanced Wheatstone's bridge. And I will prove the ulta, that if Ig is equal to 0, I will prove P by Q equal to R by S. That's what I'm going to do. For that, I need some theory that we already studied, which is Kirchhoff's current law and Kirchhoff's voltage law. First one is Kirchhoff's current law. Let's apply Kirchhoff's current law in various junctions like B and D. Let's apply KCL at B. KCL at B. At B, the entering currents are IP and the leaving current is IG. IP minus IG minus IQ equal to 0, or IP minus IG is equal to IQ. This is equation 1. Sum of the current entering the junction is equal to sum of the current leaving the junction, or algebraic sum of current at a junction is 0 with proper sign, right? That's what. Now what about at D? The entering currents are IR and IG and the leaving current is IS. KCL at D. KCL at D will give you IR plus IG, okay, IR plus IG minus IS equal to 0. So that means IR plus IG equal to IS. This is equation 2. So I applied Kirchhoff's current law at 2 junctions. Now let's apply the Kirchhoff's voltage law for the 2 loops. Okay, situation is over now. Let's apply Kirchhoff's voltage law for 2 loops. What are those 2 loops? ABDA and BCDB. Those are the 2 loops. But what is that G? G actually is the resistance offered by the galvanometer. You should remember that, right? G does not simply represent a galvanometer. G represents the resistance of the galvanometer. So let's KVL, apply KVL first for the loop ABDA. So just like this. Take the loop ABDA. And you have to remember the sign convention. You just imagine to traverse through the loop. And IR along the direction of the traverse is positive, opposite to the direction is negative. If you meet the negative of the battery first, that EMF is positive. Okay, that is the case. Now here you can write all IR. It will be IPP. Ready? IPP. You are moving like this and that is positive, plus IGG. Okay, plus IGG. And you are moving like this and current is like this, minus IRR equal to 0. So what you are getting? IPP plus IGG equal to IRR. This is the loop rule for first loop. Next, let's apply for the next loop, which is BCDB. It will be BCDB, right? BCDB, just imagine to traverse like that. IQQ, it's positive because you are moving along the direction of current. Here it is minus, like you are moving like this, current is moving their way. ISS, this again is minus, minus IGG equal to, there is no EMF, right? So that is equal to 0. So same is the reason I put here also 0, right? Because in this loop there is no any EMF, no EMF. So I summed all IR and that is equal to 0. Here also there is no EMF. There is no EMF, that is equal to 0. So you can say IQQ minus IGG equal to ISS. Okay, now that's it. Now what I want to prove, if Ig equal to 0, P by Q equal to R by S. That's what I want to prove. Imagine if Ig equal to 0. And I will name them as equation 3 and equation 4. If Ig equal to 0, equation 1 gives you, if Ig equal to 0, equation 1 gives you IP equal to IQ. Okay. Now 2 will give you Ig equal to 0, IR equal to how is this? IS, right? Sorry, it was my mistake. IR equal to IS. Now 3 will give you what? 3 will give you, put IG equal to 0. IPP equal to IRR. That's good. IPP equal to IRR, right? Now 4 will give you what? 4 will give you, this one is 4. This 4 will give you IG equal to 0, IQQ equal to ISS. IQQ equal to ISS, isn't it? See, now take this this equation as 5 and this equation as 6. If you take 5 by 6, what is 5 by 6? 5 by 6 will give you IPP by IQQ equal to IRR by ISS, isn't it? Now already IP equal to IQ. So IP equal to IQ, I can cut it here. IP equal to IQ. IR equal to IS, yes, IR equal to IS, that can be cut. So means what? P by Q equal to R by S. So I proved the reverse, that if IG equal to 0, P by Q equal to R by S. What we need, the principle is the original statement. If P by Q equal to R by S, IG will be equal to 0. Okay, this is what a Wheatstone's bridge is. Now you may be wondering why we all need all this, why we are studying about kind of bridges and all. That may be the question in your mind. Just wait, in our class we will be discussing so many problems where you will understand actually what is the need of all this. Okay, before that you will be understanding some basics to apply it on doing problems, numericals and all. Okay, thank you.